Hi, we're now going to look at position to term rules, often referred to as the nth term. Now, previously you'd have looked at term to term rules, which is where the sequence is generated by adding or subtracting a number from the previous term. In the position to term rules, we're going to use the position in the sequence together with the nth term, and we can either generate a sequence or we can go straight to a particular position in that sequence. So I've got three examples here. I'm going to find the first three terms of each sequence, then I'm going to skip, and then I'm going to find the 10th term in that sequence. So the key thing to remember here, the key skill is substitution. So wherever you see an n, instead of the n, I'm going to substitute in the position in the sequence that I want to find the value of. So for the 7n, that would be 7 times 1, which is 7. So the first term in this sequence is 7. The second term in the sequence, so our n is now 2, 7 times 2 is 14. For the third term in the sequence, 7 times 3, which is going to be 21. Skipping along all the way to the 10th term, I don't have to do the terms in between. 7n, that would be 7 times 10, which is 70. Now, obviously, this is a very simple sequence. It's easy to describe it as a 7 times table. And using the nth term, that's how we would describe the 7 times table. Now, this second sequence, 2n plus 3, well, it's going to be a little bit like the 2 times table, but it's not quite the same. Let's see what happens when we substitute in. So 2 times 1 plus 3, just running out of space. 2 times 1 is 2, plus 3 is 5. So the first term in the sequence is 5. The second term in the sequence will be 2 times 2 plus 3. So 4 plus 3, which is 7. The third term, 2 times 3 now, because we're looking for the third term in the sequence. Then I have to add 3 as well. So that would be 6 plus 3, which is 9. Now I can skip all the way along to the 10th term, or whichever term I want in the sequence. 2 times this time 10 plus 3 would give me the 10th term of 23. So you can see it is a little bit like the 2 times table, but every time we're adding 3. The final sequence is 6 minus n. Okay, so where we've got a negative n term, this means we're going to subtract the position away from 6 to give us the number of that position in the sequence. So same principle though, 6 minus 1 gives us a first term of 5. 6 minus 2 gives us a second term of 4. 6 take away 3 gives us our next term of 3. So you can see that the previous examples we had an increasing sequence, and now we've got a reducing sequence. So what would the 10th term of this sequence be? 6 take away 10, that is negative 4. So our 10th term is negative 4 in that sequence. So I hope this is helpful. Next lesson we will be looking at how to find the nth term of a sequence, but for now all you need to be able to do is to generate sequences from the nth term and go directly to a position in the sequence if you need to. Hope that's helpful.